Hello and welcome everyone to this third episode of our series of webinar about CAD, PLM, and augmented reality. I'm always Richard Bressan, account manager at Parametric Design in Canada, and thank you so much for joining me today. So this is the third episode of a series of webinar, and today with me there is my colleague Alessio Tenti. Alessio Tenti is the technical solution specialist and software developer of the augmented reality team. And today we'll be sharing some insights about the AR and the solution Vuforia. Just to remind you, Parametric Design is an authorized retailer and partner for the software providers PTC, which offers a comprehensive product suite to meet your requirements. Our range of solutions includes CAD 3D, PLM, ALM, augmented reality, and the industrial Internet of Things. Since at Parametric Design Canada, we are technology advisor for manufacturing company, today our focus is on discussing the augmented reality and the software solution Vuforia. And just to give you a sense of the opportunity here today, we can say that Canada's manufacturing sector is currently facing labor shortage. And according to the Canadian Manufacturer and Exporter, CME, these challenges have resulted in a 13 billion loss for the economy only in the past year, and reflecting loss in sales and project delays. The sector is also grappling with 65,000 job vacancies, primarily in skilled labor roles, which is affecting productivity and profitability. To address this situation, Vuforia software enables workers to handle intricate tasks with ease. Leveraging augmented reality technology, it empowers workers with real-time guidance and boosts efficiency, thereby reducing errors and enhancing customer experience. With this technology, we aim to provide a robust and competitive manufacturing industry here in Canada. And on that note, I'd like to invite you to write any question you may have during this webinar to our email address at contatti@parametricdesign.com. And now I can leave the floor to my colleague Alessio Tenti. Alessio, the floor is yours. Thank you.
Hello, everyone, and thank you very much, Richard, for your introduction. As Richard mentioned before, I am Alessio Tenti, and I am a technical solution specialist and the team leader of the AR and IoT department in Parametric Design. Before starting, I would like to remind you that if you have any kind of questions or doubt, you can contact us at our email address contatti@parametricdesign.com. Please feel free to write us and ask everything, because we are at your complete disposal. In this presentation, I'm going to talk about how the augmented reality bridges the strong gap caused by the lack of skilled workers. It is a big and a serious problem nowadays. In particular, the special role that Vuforia Expert Capture has in this situation, showing a little live demonstration of what we developed using Expert Capture, also taking advantage of a particular artificial intelligence functionality that helps the operators while carrying out the AR procedures. This is a little agenda we can follow to go through all the topics. We can start with a general introduction on what AR is and the devices that can be used. Then we will go through the combo of problem, solution, and the use case. The problem of the lack of skilled workers, the solution, so the software used to fix the problem, and the use case we developed. So the software, the solution, the software is Vuforia Expert Capture. It is a PTC software, and the use case we developed is a disassembly sequence of an industrial valve. Also using, as I mentioned, the AI step check functionality, that is artificial intelligence functionality that can help a lot the operators in the industrial operations. But firstly, what is AR? The augmented reality is a technology that enriches the sensory perception through the usage of the digital information that will not be perceivable with the five senses, especially with the sight and the hearing. This type of digital information can be, for example, sounds, images, videos, or more commonly 3D objects superimposed on the reality. We can therefore speak of integration between physical reality and the digital world through the use of common devices such as smartphones and tablets, or more sophisticated ones like wearable devices, smart glasses. And so, what are the devices used? AR can be used on a variety of devices. Anyway, a big distinction must be made between two categories of devices, wearable and non-wearable. The wearable devices are particular devices that allow you to take advantage of the AR in hands-free mode. So, for example, having both the hands during the use. The main wearable devices are the Microsoft HoloLens, that are particular viewers that allow you to view 3D holograms in space and gives you the ability also to interact with them by touches, moves, voice, or for example also gestures. Then there is a RearWear, that is a visor helmet with a small screen that can be positioned in front of the eye, and that allows you to view 2D elements as if they were 3D in space, because the small screen is very, very close to the eye, and so gives the illusion of 3D, even if they are 2D elements. Then there are other glasses, for example, the Google Glass, or maybe the most recent Apple Glass. And then, as for non-wearable devices, we can commonly find smartphones, tablets, webcams, and so on. But what is the main problem? What is the lack of skilled workers? As the complexity of manufacturing increases, the workers themselves become a barrier to growth. So there are two main problems. Firstly, many skilled workers are reaching their retirement, so leaving a significant skills gap in the manufacturing workforce. And then the second one, the problem is their replacements, because the millennial workforce, for example, or third-party contractors and retrained workers from other industries lack experience, and so can be very, very difficult to reskill. And so what is a possible solution? A possible solution is the Vuforia AR product suite. For example, Vuforia Expert Capture. Expert Capture is an application available for wearable devices, such as, for example, Microsoft HoloLens and RearWear, and allows you to record the guided steps to carry out operations, for example, machine onboarding, or more in general on machinery and or objects. During these recordings, the expert operator can document a set of step-by-step operations through real-time videos, photo snapshot, voice, textual notes, and even also 3D position indicators, which will be suitably positioned on particular components on the objects that are being documented. These recordings are then fed into Vuforia Editor, that is an out-of-the-box platform that allows you to generate guided procedures, both from scratch or by using the recorded material with Expert Capture. Furthermore, Editor is a closed and secure platform and already implement a management of user roles, for example, simple viewer or author of procedures or general administrators. Once created, the procedure can be then published and viewed from both wearable and mobile devices through the use of Vuforia Vantage. Vuforia Vantage, with which the operator has the possibility to perform the previously published procedures and to be guided step by step to the completion of these procedures. And what we developed, the use case is the disassembly sequence of an industrial valve. So firstly, as you can see on this small video, we used Creo Illustrate, that is a PTC software, to create and define the disassembly steps for the valve. Here can you see a small preview video of the disassembly sequence, starting from the first step to the last one. Then from Creo Illustrate, we exported the sequence into a Vuforia procedure file that is a special extension file, is a .vpfz extension, and this file can be imported into Vuforia Editor to automatically generate a procedure based on the steps created in the sequence. Then we used the Vuforia Expert Capture on HoloLens to record some videos while we carried out the disassembly steps if we were an expert, adding some 3-point indicator and some important elements. Then these recorded sessions have been imported into the platform Vuforia Editor. And afterwards, we reorganized all the material we generated in the previous points, and we created the procedure with all the steps. We also added the AI step check functionality that use algorithms of artificial intelligence that can match the real-time view with picture taken previously in order to give real-time feedback. And so the operators with this special functionality can be guided to decide if a particular step is passed, so green check mark, or is failed, so a red check mark, red X, for example. At the end, we published the procedure on the Vuforia Cloud, ready to be opened and executed on Vuforia Vantage using mobile or wearable devices. And now I will stop sharing my presentation and I start to share the Vuforia Editor platform on the internet. And I also reset my camera on. Okay. So this is the main page of the Vuforia Editor platform, showing our previous projects and demos. Now I select industrial valve disassembly. And so, as you can see, in this folder, we have all the medias linked to this project. You can see the images generated with Creo Illustrate. So for each step, there is, for example, the step 1 image and the step 2 image, and so on. And also there are the videos generated, the animation videos generated on Creo Illustrate, and also the videos generated with Expert Capture using the HoloLens. The very first item is the Vuforia procedure called Industrial Valve Disassembly. So if I open it, we can see a different page. We will see now two main columns. On the right, we have all the steps created for these procedures. So from the step number 1 to the step 15. Okay. And then on the left side, we have the 3D model of the bulb, 3D interactive model, because I can select and choose all the 3D parts. I can also rotate the model, change the position of the model, and so on. If I go back on the right column, we can see, for example, the step 1. So each step has a feedback type. There are 4 different feedback types. The first one is the none, so no feedback is required. So the operator that use this procedure on runtime, when he performs the first step, he can go to the next one without any kind of feedback. But if we choose the confirmation feedback, the end user must explicitly confirm the step completion through this clickable checkbox. So I have selected the confirmation, so when the step is completed, the operator has to check in order to confirm and go to the next step. A different one is the pass-fail feedback type. The end user must provide feedback about whether or not an item meets the step criteria. So if he decides that that step is passed, he has to click on the pass button, on the green check mark. If not, he has to click on the fail one, so red button. And then the last one is the most interesting, sorry, and it's the feedback type that used the step check AI functionality. So the pass-fail feedback is supported by an algorithm of artificial intelligence. And then we can see on the first step. By the way, we can start with the first one. So the first one is remove the handwheel nut. So we have also media, so the step 1 image that represent the end of the step 1, so the 3D model without the handwheel nut, as you can see. The step 1 video, so the Creo Illustrate animation of the removing of this handwheel nut. You can see again. And then the video that I have recorded with expert capture, while I'm removing the handwheel nut. Then the second one is quite similar to the first one, is remove the handwheel. So if I open the step 2 image, we can see the end of the step 2, so the 3D model without the handwheel. The step video, so how I can remove the handwheel, is quite simple. And then also the step 2 video recorded with expert capture. And then always mean that I can remove the handwheel. Okay, and then we are on the first step. The first step is the step that requires to use the step check functionality. And the sentence of the first step is to check that all the screws are in place. So what I did, we trained the AI model in order to check if all the screws are in place. So all the 6 screws are linked, are in place. So if only one or more than one screw is not present, the AI algorithm automatically failed that step. How we did that? We used the step check AI functionality, and that use the images in order to check the step. So we took a lot of images, about 500 of images, and I can show you on the dashboard. We took about 500 images, images that represent the case, okay, the cases, because as you can see here, this kind of situation, this kind of scenario is a failed one, because there is a hole, there is a missing screw, and so I marked this kind of photo as failed. And so we did that with a lot of images. Now if I scroll down, we can find other images, for example, showing the valve with 2 holes like this. And so also in this case, this step is failed because there are 2 holes. And then if I scroll down more, we can find the past images. So these images are representing the good condition, the good scenario, because all the screws here, okay, we only see 4 screws, but there are also other images that can show all the screws like this. We have 6 screws in place, and so this image is marked with pass. So we have 216 pass images and 280 failed images. We launched the algorithm that trained the model, and so the application automatically helps the operator to automatically decide if the step is passed or is failed. Okay, now I think that I can show you in real time how the application works. So I start to share my iPad. One second, please. Okay, now I am on my iPad, and so I need to select the Vuforia Vantage application that is on the bottom right of the screen. So I press Vantage, and now the application is opened. I have already done the authentication previously, so I'm already authenticated. Now the 2 ways to select the procedure are or selecting it on the library like this, or just scanning a QR code of the procedure. For the moment, I choose to select it on the library, so I choose industrial valve disassembly, and now the procedure is opening. Firstly, I can see a preview of all the steps of the procedure. So on the right we have the step list, and on the left we have the version, the last published date, and so on. And so I click now on start session, and we can start with our session. So step 1 is remove the hand wheel nut. So for each step we have a photo taken from Creo Illustrate, the animation video taken from Creo Illustrate, so you can see that the nut is disappearing, and then the video taken with Vuforia Expert Capture. So in the video there is me that I remove the nut, and so this could help the operator to do the operation. So due to the fact that the application in this kind of step is not able to share the video, I temporarily change the application, and I go on the camera so you can see my action. So I go there, and I unscrew the nut and remove the nut. Okay. Then I return to Vantage, I confirm the step, and I go to the second step. The second step is to remove the hand wheel. So this is the image. I press for the video, so you can see the video from the Creo Illustrate. Let's see again the animation. And then there is the expert capture video. So there is always me that I remove the hand wheel. And now I change the application and I go back to the camera and I will remove the hand wheel for a moment, just with one hand, because with the other hand I'm taking the iPad, and so I removed the hand wheel. And then we can confirm and then go to the first steps. The first steps is a different one because it's use the step check AI functionality that I have mentioned before. The recognition was too fast, so I will redo the recognition, and maybe I don't focus for the moment the valve, because okay, you can see that there is the model target, so the border of the valve, and now if I match the valve with the border, the application recognizes that there is the valve, and so if I go on the other side, the marker will remain at the same position because the application recognizes that the valve is there. And so the signature tells that to check that all screws are in place. Okay, so automatically the application said that okay, all the screws are in place, and so there is a green check mark, the green check. But what if I remove one of the screw? So I have previously removed also the nuts before, so it's more easy. And then if I remove the nut, automatically the procedure says that okay, all the screws are not in place because there is a missing screw, and then the step is failed, is not passed. If I try again to remove another screw, obviously the step is not passed. And if I try to re-put the first screw, again the step is failed. And so now if I put the second one, automatically the application said that the step is passed. So this is the reason why artificial intelligence is very important, because it can save a lot of time and then can help the operators to take a decision, maybe hard decision, or the decision smarter and faster. And so now I think we have completed our presentation. Thank you very much for your attention. And I would like to remind you that for any kind of doubts or questions or requests, you can write us to our email address, that is contatti@parametricdesign.com. Thank you, and now we can go back to Richard.
Well, thank you very much, Alessio, for such a great presentation about the augmented reality and Vuforia. So this marks the end of this third webinar. I hope you enjoyed, and I will look forward to see you again for the next webinar, which will delve into the application lifecycle management, ALM. And a special thank you goes to our marketing department for the hard work in putting this together. And remember that Parametric Design will remain available to assist you after this webinar anytime. So please don't hesitate to contact us at contatti@parametricdesign.com for any further question or information. Once again, thank you all for participating, and have a great rest of the day. Bye-bye.